Good morning, students. Today, I would like to further explain design of shaft. In previous lecture, students already discussed about how to design a shaft on the basis of vertical loading diagram, that is on the basis of maximum shear stress theory. Already discussed or to find the reactions and bending moment at point B and C, that we have already calculated the bending moment at point B and bending moment at point C. So the next step is you have to consider horizontal loading diagram. Similarly, for horizontal loading diagram, here you have to consider A and D as a reactions point, and on B and C, these are the on the point B and point C, where you have to consider here loading as a P3 plus P4, that is on the pulley C, horizontal load is acting. And similarly, here again our aim is to find the reactions at point A and at point D. How to find reactions, students? Here we have to take the moment, or by taking moment about point A means what? We have to consider the right side forces of point A. Here the right side force or forces are nothing but P3 plus P4 equal to 7352.94 Newton into perpendicular distance between that point C and A is nothing but 800, and the moment here it is clockwise moment, that's why it is take a sign as a positive, minus reaction here or second load, that is vertically upward, is RDH, that is reactions, minus RDH into perpendicular distance between point A and D is here 1000, and sign for this is nothing but negative because it is anticlockwise moment. So by evaluating the given equation, we can get answer for reaction at point D, that is horizontal reaction at point D, RDH is equal to 5882.35 Newton. Next step is to find the reaction at point A. How to find reaction at point A? Here we have to take summation of all vertical forces is equal to 0. Means here vertical forces are RAH plus, that is vertically upward, that's why it is plus 5882.35 minus 7352.94, that is equal to 0. So here RAH, if you have to evaluate this equation, RAH minus 1470.59 means reaction at point A. The answer for reaction at point A is 1470.59 Newton. So here in this way already found the reactions or values of reactions. The next step is find horizontal bending moment diagram at point A, B, C and D. How to find bending moment at point B, C? You have to just consider either left side forces or right side forces of point B. So you have to just consider left side force to calculate bending moment at point B, that is MBH is equal to left side force to the B is RAH is equal to 1470.59, and it is clockwise, that's why here we consider it as positive, that is positive plus 1470.59 into perpendicular distance between point A and B is 200 mm. Let us calculate bending moment at point B, that is horizontal bending moment, and answer is 294118 Newton meter. Or in another way we can calculate the same bending moment at point B by considering right side forces of point B. Here right side forces are nothing but force C at point C and at point D. These are the two forces acting to the right of B. So find bending moment at point B, horizontal bending moment, that is equal to minus 7352.94. Here minus sign because it acts as a clockwise direction, anti-clockwise direction, that is 7352.94. To the right side it is clockwise is negative and anti-clockwise is positive, into 600, that is perpendicular distance between P3 plus P4 load is acting clockwise about point B, and to the right side we have to consider clockwise as a positive and anti-clockwise as a negative. And next force is 582.535, that is reaction at point A, and that force is acting anti-clockwise about point B, and perpendicular distance between point B and point D is 800 mm. So just calculate given equations. We got the answer for bending moment at point B, that is horizontal bending moment, equal to 294,118 Newton meter. That means we got same answer for either left side or for either right side. Next is to calculate bending moment at point C. Here again we have to consider right side and left side forces about point C. For right side force, you know that anti-clockwise force or anti-clockwise moment about point C is positive and clockwise is negative. Here for right side the force is here right side 147059.8 into 800, that is left to the point C and right to the point C is RDH 582.35, means you got the same answer. Bending moment at point C, horizontal bending moment, that is equal to 1176472 Newton mm. So in this way we have calculated the values for bending moment at point B and at point C. Then next task is to find resultant bending moment at point B and at point C. How to find resultant bending moment at point B and C? We have to just use one formula, that is equal to under root of MBV square, means vertical bending moment about point B square plus horizontal bending moment at point B square, means we have already calculated the bending moments at point B for horizontal and for vertical loading, and by putting the values of bending moment at point B vertical and at point B horizontal, by evaluating the equations we can get answer for bending moment at point B equal to 657,667.84 Newton mm. Then next bending moment at point C, that is again we use the same formula to find the resultant bending moment at point B and C are, that is equal to under root of MCV square plus MCH square, that is bending moment at point C for vertical plus square plus bending moment at point C horizontal square, that is whole square under root of this. Then you have to just calculate bending moment at point C, and we get answer for bending moment at point C is 1185627.43 Newton mm. And by taking the maximum bending moment, here maximum bending moment is 1185627.43 Newton meter, and from this we just draw a bending moment diagram, that is here this triangle is nothing but bending moment diagram or horizontal loading, that is at point A and D bending moment is 0 because these are the endpoints, and here we have already calculated the values for bending moment at point B and bending moment at point C, that is resultant bending moment for point B and point C, because here we consider horizontal loading diagram. So here the bending moments are positive, means we got positive bending moment diagram for this particular horizontal loading condition. So next is, last step is to find the shaft diameter. How to find shaft diameter? We know that we have equation tau max, maximum shear stress, equal to 16 upon pi d cube under root of mb square plus mt square, that is maximum bending moment square plus bending moment in bending and bending moment in torsional bending moment, that is bracket square, which is nothing but tau max. We know that maximum shear stress, it is 66.67, that is equal to 16 upon pi d cube under root of, or to just put here values of mb and mt, that is torsional bending moment and bending moment, that is resultant bending moments. So by just evaluating the given equation, so we can get diameter D as 45.47 mm, that is means approximate value of diameter D equal to 46 mm. So here the end of numerical first from for design of shaft based on maximum shear stress theory, that is from unit number 2, that is from unit number 2, design of shaft keys and couplings. Thank you.